Hello, welcome everyone. In this video, I'm going to work on the derivatives of natural log functions. Here we have a function, which is the natural log function. So we have ln of 5x squared plus 3x, and we want to take the derivative of this function. So this is what we're going to do in this tutorial. So I'm going to write this y equals ln of 5x squared plus 3x. Okay, we want to take the derivative of this. So when we take the derivative of natural log functions, we turn the natural log functions into the exponential form. So I'm going to write this e to the y equals e to the ln of 5x squared plus 3x. Okay, now here we have to know a couple of properties. One is that if we take the we have a base, we have a, and we take the log of some number b with base a. So we are raising the a to the log of b with base a. This is equal to b. And the other thing that we need to know is that the natural log actually is the log, the common log with base e. Okay, e is the Euler number, and we actually use it in our similar to pi has a value, so it's a constant, and we use in our exponential functions as a base. And the other thing that we have to know is that the derivative of e to the x, okay, is e to the x. I have done that in another video, the derivation. So this is what we get when we take the derivative of e to the x. But if we take the derivative of e to the u, d over dx of e to the u, it's not just e to the u, it's going to be e to the u times du over dx. Okay, and because u is a function of x, so when we take the derivative of e to the u, it's going to be e to the u times the derivative of u itself. So this is another one that we have to know. So this is first one, second one, and third one. And one more, if we have e to the ln of a is equal to a. So this is our fourth identity we need to know. All right, now we can go ahead and actually solve this. So e to the y equals e to the ln of 5x squared plus 3x. So this portion right here, we can use this identity. E to the ln of a is equal to a. So e to the y equals then just 5x squared plus 3x. Okay, so we use this identity, e to the ln of a equals a. So e to the ln of 5x squared plus 3x is then just 5x squared plus 3x. All right, so now e to the y equals 5x squared plus 3x. Okay, now we take the derivative on both sides. D over dx of e to the y equals d over dx of 5x squared plus 3x. Okay, now the derivative of e to the y, we already learned that derivative of e to the u equals e to the u times du over dx. So similarly, derivative of e to the y is going to be just e to the y times dy over dx. And on the right hand side, we can take the derivative of these terms separately. So we're going to take d over dx of 5x squared plus d over dx of 3x. Okay, now e to the y times dy over dx. Now if we take the derivative of this 5x squared, we can pull 5 out, and then we just take the derivative of x squared, which is just 2x. And similarly here, the derivative of 3x, we can pull the 3 out from the derivative. It's a constant, and then derivative of x is just going to be 1. So here we get e to the y dy over dx equals 10x plus 3. And now we divide both sides by e to the y. So divide by e to the y, and here e to the y cancels out e to the y, and we are left with dy over dx equals 10x plus 3 over e to the y. And then we can go ahead and plug in the value for e to the y is 5x squared plus 3x. So this is our final answer for the derivative. Okay, so dy over dx is equal to the 10x plus 3 over 5x plus 3x. So this is the derivative of this logarithm function, the natural log function. Hopefully this helps.